Assalamualaikum. For task 1 is analysis of electric field between electrodes. Sphere gaps are commonly used for measurement of peak values of high voltage. So here we have two sphere electrodes. Each electrode has a radius of 25 mm and the electrodes are separated by a sphere gaps. So for the simulation, we will apply high voltage in the upper electrode and another electrode will be grounded with 0 volt. And then we will observe and analyze the electric field produced between the sphere gap by using electrostatic problem in FEMM software. And then later we can see that the electric field will be higher at the higher voltage level here. So in this video simulation, I will show the simulation when the sphere gap is increasing from 1 cm to 5 cm and 17.5 cm with the corresponding voltage. Then we will see the differences of the electric field produced in the boundary. Okay, first we will draw for the gap distance of 10 meter and voltage applied is 31.4 kilovolt. Since this is an symmetry, so we only draw half because the other half will be symmetry. So this space is the boundary and the boundary is filled with air with a permittivity of 1 and the electric field will only be seen inside this boundary. So first of all, we have to set the properties. So first is material, air. The air will be relative permittivity of 1. Okay, and then we insert property for boundary, which is open BC and 0. And then for the conductors, we will insert ground for the below electrode, and then the upper electrode we will vary with 31.4 kilovolt, 136 kilovolt and 362 kilovolt. Okay. Now we will define each line as 0 boundary. Then the upper arc will be defined as 31.4 kilovolt. The lower arc is grounded and the boundary arc is open BC. So to simulate, we create mesh and then turn the crank, and this is the result. As the result of the simulation, here we can see the gradient of the voltage intensity. You can also see the gradient for field intensity. So this is the field intensity. At the gap, there is a higher field intensity. So now we will plot for voltage versus distance, and we can verify that the maximum voltage is 31.4 kilovolt at the lower arc, and then after the 10 mm gap distance, the voltage is 0 at the lower arc, which is ground. And then for the electric field intensity, so we can see that the maximum field intensity is around 3.5 mega kilovolt per meter. Similar step will be done for a gap distance of 5 cm and 17.5 cm. So this is the distance for 5 cm gap. We will define the upper arc as 136 kilovolt and the lower arc as ground. So this is the simulation result. We can see the gradient of voltage and the gradient of field intensity. Okay, so now we will plot for voltage versus gap distance. We can verify that the maximum voltage is around 136 kilovolt. And then plot for magnitude of field intensity. Here the maximum field intensity is around 4.75 megavolt per meter. Okay, for a bigger gap distance, which is 17.5 cm, we will define the upper arc as 362 kilovolt and the ground arc as ground, 0 volt. And the simulation, you can see the gradient of field intensity. The field intensity becomes greater as the gap is increasing. So as we plot for voltage versus the gap distance, we can verify that the maximum voltage is 300, like around 362 kilovolt. And then plot for the magnetic field intensity. So the maximum field intensity is around 7.4 megavolt per meter. So now we can see the difference between the smallest gap and a bigger gap and a greater gap distance. So when the gap distance become increasing, so the maximum electric field will also increasing.